So for example, let's evaluate the integral of 5x to the 2/3 plus 7x to the 1/3 dx. So I'm going to use the rules from chapter 5 for integrating. I'm going to keep the constant coefficient 5. For x to the 2/3, I need to add 1 to the power, and I'll divide by the new power. Then going on, I keep the plus sign. I keep the constant coefficient 7. And for x to the 1/3, I'm going to add 1 to the power and divide by the new power. And I have my plus c. Okay, 2/3 plus 1. If you need to go off to scratch paper and do that, that's fine. 2/3 plus 1 is the same thing as 2/3 plus 3/3, so that's 5/3. Do that off on scratch paper, though. I mean, I don't care where you do it in the notes, but when you're turning stuff in, that's the kind of thing that you just want to do on scratch paper and not clutter your work up with. Okay, anyway, so I have x to the 5/3 divided by 5/3 plus 7 times, and then x to the 1/3 plus 1, well, 1/3 plus 1 is 4/3. And I have plus c. Now I need to clean this up, and remember, you divide by a fraction by multiplying by its reciprocal. So dividing by 5/3 is the same thing as multiplying by 3/5. And similarly, in the next term, we have a division by a fraction, which is the same thing as multiplication by the reciprocal of the fraction. So I have 7 times 3/4 times x to the 4/3 plus c. In the first term, the 5's cancel out, leaving me 3x to the 5/3. I guess no cancellation happens in the second term, so I'm just going to go ahead and multiply the two fractions. I say two fractions because I'm thinking of 7 as 7 over 1. Multiplying straight across, I get 21/4 times x to the 4/3 plus c. Now I look at this answer and I really have no idea if this is right. I don't really have intuition as to whether this should be the integral or antiderivative of the thing I started out with. If you're doing homework, you can often look in the back of the book to see if you've got the right answer. But of course, on a test, you don't have access to the answers. So what I would do, after I finished the test, if I had time at the end, I would check. Now, you do not have to show me that you checked your answer. You can do this off on scratch paper. So I'm thinking of this thing that I was integrating. That's like my little f of x. And the antiderivative is like the capital F of x. And if our answer is correct, then we should have the derivative of our answer being equal to that original function that we were finding the antiderivative of. Okay, so we're just going to check that the derivative of 3x to the 5/3 plus 21/4 x to the 4/3 plus c, that derivative should work out to be the original function. So let's just differentiate. I keep the 3. I bring the 5/3 down front. I subtract 1 from the power. 5/3 minus 1 is 2/3. Then I have plus. I keep the 21/4. I bring the, that was supposed to be a 4/3 power. Okay, I bring the 4/3 down front. I subtract 1 from the power, and 4/3 minus 1 is 1/3. The derivative of any constant is 0. And let's see, doing some cleanup here, the 3's cancel. In the second term, the 21 cancels with the 3 to give a 7, and the 4's cancel. So I have 5x to the 2/3 plus 7x to the 1/3. Is that the function I started out with? Yes, 5x to the 2/3 plus 7x to the 1/3. So that tells me that my antiderivative answer was correct.